Good afternoon, everybody. Welcome to our session. Something that's very interesting. I'm hoping that we get some real good insights from one of the major providers of 5G services in the USA today. And so we have Dave Pirrocco, Distinguished Architect at Verizon. And this should be a very interesting session about how we're going to use all this great new bandwidth you guys are providing for all these great new video services. So I'm really looking forward to this. Thanks, Dave.
Thanks, Wes. Good afternoon, everybody. My name is Dave Pirrocco. I'm with Verizon, and I want to tell you a little bit about me, and we're going to talk about 5G video streaming. We're going to talk about different use cases, architectures. Okay, all right. A little bit about me. I've been with Verizon for 19 years. I'm a distinguished architect in the 5G and MEC strategy and innovation team. And then my other day jobs, I chase big waves in Nazaré, Portugal, and I currently was on 40 footers there, so that was kind of fun. And then one of my other jobs outside of Verizon is that I do mixing and mastering for major album projects for a lot of artists that you know and love. That one being one of them. So what we're going to talk about today, I'm going to cover some of the basics leading up to these great use cases that we're talking about here. So 5G, what is 5G in terms of comes in different flavors. And what we're talking about today is we're talking about millimeter wave, which is what's running in the venue here today. We're able to, I was pulling over that, pulling down this morning around, it was about 3 gig down, 100 meg up. It has great speeds. The coverage varies because it's millimeter wave. It has some sensitivities because the waveform's so fast to objects and stuff like that. So what we're doing with it is we use it in venues like this and in saturated locations like airports, train stations, etc. And we're combining that with C-band. And C-band gives us better coverage. It's a good mix of speeds, very dense coverage, and the speeds that you could see on C-band are 300-400 meg down. And then low band, I put low band in here. I think of low band, I'm thinking more, I'm not even thinking 5G, I'm thinking, we'll talk LTE. And with that, you have very dense coverage, but the speeds are a lot lower. So primarily for what we're talking about with what we're going to go over here is stuff that we've done with millimeter wave, and then also with LTE, believe it or not. So we have two different types of networks to consider when deploying or doing video streaming. Public network, which is the commercial network here that you could connect to with any device. And then we also do private infrastructures too. So in the absence of network slicing or for more security conscious folks, we can build out private networks that can isolate the traffic and then be discrete from, like in a venue like this, you could have a private cellular network that's working in addition to the commercial one so that the traffic's all separated. The building blocks to all this, to video streaming, so we're talked about 5G a little bit and the different types of 5G connectivity in both public and private. Now we're going to talk about multi-access edge computing, what it is. And so the idea behind this is that in your traditional cloud model, you have to go back to, you have to go back to a region, to an availability zone that's in a cloud provider's data center. And so what that does for devices is it requires a lot of heavy processing to be done on the device side. Battery consumption goes up on the device side because of that. What we're doing with a distributed cloud model with MEC is we're moving edge compute closer to the end users. And the way we're doing that is we're standing up public MEC nodes. We have 17 of them deployed throughout the country. They're stood up in what are called our service aggregation points. Those service aggregation points serve, that's where all of your cell towers basically connect in a metropolitan area. It's like a meet-me point. Think of it that way. And so that compute is living there. And what that does for us is that allows us to bring a compute fabric to the mobile network closest to user. That service aggregation point covers around an 80 to 150 mile range. Mileage may vary, but you get a good mix of you'll be able to pick up in a metropolitan area. You could pick up and talk to a compute node pretty much anywhere. There's two different flavors of MEC, much like what we had with I talked about public and private networks. We have two different flavors of multi-access edge compute or mobile edge compute. Public, that's the infrastructure that I just talked about a little bit. I touched on it, the 17 locations. That's a multi-tenant infrastructure. We're partnering with AWS for that build out. And then the latencies that you could expect on it are around between 7 to 20 milliseconds, depending. And at the CRAN, and then 20 to 80 milliseconds at the SAP. To be honest with you, this is the legal slide, but we consistently see between 10 and 20 milliseconds in the SAP. It just depends where you are, but that's the kind of latency. Those are the latency numbers that you're dealing with. In a demo that we have in our booth with a contribution use case, we're actually getting 7 milliseconds to the Las Vegas MEC node from here on the commercial network. Private MEC is just what the word says. It's a single user, it's a single tenant kind of infrastructure. It's dedicated and it's harnessed with or coupled with a private 5G/LTE network. So the use cases for this could be in venue or on campuses, those types of things. So why is all that important? Because showing you those building blocks, now I can expand upon that and show you the video architecture that we're talking about here and what we can do with it. So I talked about our MEC nodes. The MEC nodes are here, right? So what we've built within AWS is we have a set of virtual distribution hubs that live in 2 different regions. And then those hubs are actually living in AZs in each of those regions. There's a compute node that's in the front end of that distribution hub that acts as an ingest cluster. So I could take an origination signal, bring it in, hits the ingest cluster, and then within Amazon, what we built here is a combination of this virtual distribution hub, and then that's fanning out to media gateways that live in wavelength zones. And so the way this architecture works as a whole is basically you have 2 different subnets. You have a VPC created in Amazon. You build in an AZ this piece in one subnet, and this stuff's living in another subnet. And it's the operation between it's fairly seamless. Then that traffic will hit what we call a carrier gateway. That carrier gateway is what faces the mobile network. On the other end of that, you have your tower, then we have a 5G receiver/router, and then your endpoint. So that's the architecture at the design pattern at a high level. You could do the converse of that for contribution. So what we're showing here is distribution, and if you want to see this in action, we have both contribution and distribution workflows being demoed live in our booth. So media gateways, this concept of a media gateway, and what we're doing here is it serves a local market, right? So you're able to ingest, think of it as an on-ramp and an off-ramp for your video sources in a major market. So New York, we have them in 17 locations today. So you could build this in any of them, and the key components of it. I think I showed that on the other slide, but again, you have a video source coming into a feeder, hits an ingest broadcaster or an ingest piece of software, hits some pass-through clusters, and then hits the media gateway on the other end. It provides access to other services leveraged by the workflow. So when you think about this construct, while you have a media gateway in the public MEC node, the wavelength zone, you could also have other things that complement your workflow sitting there as well. So things like graphics packages, some playout components, depending on what you're doing. These are things that can potentially be facilitated through that. What we're doing today is a combination with multiple partners to do both delivery, distribution and contribution. So the way the traffic works in this is a contribution use case. What you have here is you have the remote location. It's feeding a 5G, so that camera on the end, or aggregate of cameras, hitting a 5G router with a 5G modem in it, being brought into the carrier gateway, being ingested in that media gateway fabric, and then it comes into the virtual distribution hubs and can be fanned out back to a production center, to remote users that are working on the production. So you could have it creates the idea of having a distributed workflow in terms of different folks being able to work on that content. This is the high-level design for distribution. It's basically the work, point of origination, ingest, distribution hubs, then out to media gateway, which then feeds your cellular network, and then your endpoint. These wavelength zones, again, what's key about them is that they're in 17 locations today, and the latencies that we're seeing on them are really useful for both contribution and distribution. So in terms of resources, I've put up a few resources here that you can peruse at your leisure. One of them is about our 5G edge compute platform itself. Gives you all the information on that. The other thing that we have is a developer resources page where that reference architecture that you saw on screen, there's a write-up and that you'll find that there, as well as some tutorials. We're building native services into this as well. So there's things like what we call our edge discovery service that you could couple with applications so that you can pick the best, most performant MEC nodes to use. And that's pretty much it. Thank you. I have some other, we're on a panel tomorrow. You could come check us out. We'll be talking about the business side of this a little bit and how we're handling broadcasting and distribution through broadcast contribution distribution with mobile edge compute and that. So I thank you.
Thank you, Dave. All right. I think we have a question or two.
I mean, 5G is great for downloading, but you introduce it for TV production. So do you say we get a meg or two? Or I mean, the uplink is not very impressive.
So yeah, upload speeds we're showing single camera use cases with it, and with that you're getting, we're getting like, what, 40, 50, between 40 and 70 meg in here. It was varying as an upload speed. So if you compress out of and then with one of our partners' technologies, so with LiveView, for example, them taking that signal, compressing it off the jetpack, and sending it in.
I mean, compresses die. LiveView is not doing APXS, which will save the day for you. But can you have balanced network in 5G? Get a fair uplink.
The way in 5G, the way the network's tuned right now with an 80-20 rule, 80 being down and 20 being up, that's the consumer network. when you build out, if you were to build out a private network, you could tune that. You could tune tune the uploads and downloads on that. Now for venues, that would be a good solution. So you could actually tune your speeds more. On the commercial network, it'll mature over time where those numbers may get a little bit better. But for now, the working numbers that we're dealing with are I see it more as like a single camera kind of news gathering kind of, that type of thing. Or if you're doing some kind of live streaming event and you're using something like Sling Studio or something like that, and you could stream out from that.
If I want to do an NDI today that needs 150 to 100 megabits, I will definitely need to bond with this solution. I need to have, with the NDI, the basic concept is to have low delay. So if I want to do that over 5G, basically, right now it's undoable. The only way is to do that by one LAN connection to the wavelength, right?
NDI on it? No, not yet.
Is that the service provider, the Zigbee solution that limits that, or it's capabilities?
We haven't tested NDI because we just haven't explored. We haven't had any demand for what we're doing. We haven't had any demand for NDI. We see it coming, but we haven't done any real testing with it because we were testing basically a distribution use case and then simple contribution use cases.
Okay, Dave, thank you very much. Appreciate it.